This video is intended to help you understand how automation could affect inequality. So consider a hypothetical economy composed of 80 workers and 20 owners. We're going to make this economy similar to the US today, so the average income is $60,000. The poorest 80% of the population receives 40% of GDP. Right? Here we see we've ordered the population. We have 80 workers and 20 owners, and the 80 workers together get 40% of all the income. That means the richest 20% are going to get the other 60% of all income. For simplicity, we're going to assume that all 80 workers are identical and that all 20 owners are identical. So every worker receives $30,000 in wages, and every owner receives $180,000 in profits. To make sense of that, right? If you have 80 workers, or 80% of the population, receiving 40% of GDP, right? That means that they're each receiving half of GDP per capita, right? Because 80% of the people are splitting up 40% of the income, right? That's how we get, since GDP per capita is $60,000, that's how we know the wages for everyone are $30,000. And similarly, since 20% of the population is getting 60% of all the income, that means those owners are all receiving 3 times GDP per capita. Since GDP per capita is $60,000, they're each receiving $180,000 in this example. So the figure on the right shows a Lorenz curve for this economy, right? Where we have workers here and owners there, right? As well as areas A and B, which we can use to calculate the Gini coefficient, right? Remember, the Gini coefficient is always equal to the area A divided by the area A plus B. As in homework 2.2, it's easiest to calculate B and use that to calculate A. And in this case, it's easy to do it without a spreadsheet because we only have a few triangles, right? In the previous example, you had data for 10 different deciles, but here we only have 2 groups with the same income, so it's pretty easy to do by hand. First, we want to calculate the area of this triangle here, this part of B, right? That's equal, has a base of 80, a height of 40, and you have to divide it by 2 because it's a triangle. It has an area of 1,600. This rectangle here, right, has an area of 20 times 40, or 800. And this triangle up here has an area of 20 times 60 divided by 2 because it's a triangle of 600. That means that B together has an area of 1,600 plus 800 plus 600 of 3,000. Since A plus B equals 100 times 100 divided by 2, it equals 5,000, right? We know that means A must be 2,000 if B is 3,000. The Gini coefficient then, which is A over A plus B, is going to be A, 2,000, divided by A plus B. A plus B always adds up to 5,000, right? It's 2,000 divided by 5,000. The Gini coefficient is 0.4. So this is what you're given at the beginning of the problem. Now, it's worth noting that this is similar to the actual data for the United States in figure 19.1 of the book, which shows that earnings inequality in the United States has a Gini coefficient of about 0.48, right? We're at this bar here. After taxes and transfers, the government reduces that, but if we just look at inequality of pre-tax income, we're on the green bar here. The inequality in this hypothetical economy is slightly lower because there are no differences in income within the bottom 80% or the top 20% of the population, right? Returning to the figure we had, right? If you imagine instead that this point was set, and of course this point here and this point here are set, but if you imagine this being curved instead, we would have gotten a slightly larger area for A, a slightly smaller area for B, and the Gini coefficient would have been maybe 0.48 instead of 0.4. So the first part of the problem, you're asked the following. Suppose that the owners develop a new robot technology that replaces 40 workers. For simplicity, assume it costs nothing to build these robots, and that the owners continue to pay the remaining 40 workers $30,000 a year. Draw the Lorenz curve for this economy when the owners have the robots. Well, how would this affect inequality? Well, now the poorest 40 workers would be unemployed. So instead of receiving the $30,000 a year they used to receive, they would receive nothing at all. This would give us a Lorenz curve. For the first 40 workers, it's completely flat, telling us that the poorest 40% of the population collectively get 0% of the market income. The next 40 workers are now going to receive 20% of all the income, rather than the 40% that the poorest 80 got before, right? So the idea here is that the Lorenz curve here is going to have exactly the same slope it had here, right? But now it's only 40 workers that get that $30,000 a year, so that the poorest 80% of the population, the poorest 80 people, collectively only now get 20% of the income instead of the 40% they got before, since half of them are unemployed, and since those who are employed get no more income than they received originally by assumption. And then the 20 owners are going to receive now 80% of income. The 60% that they received originally, plus the 20% that now goes to the robots, which they own. Giving us a Lorenz curve now that's further down from the line of perfect equality than the original Lorenz curve. What's the Gini coefficient for this economy when owners have robots? Well, what we want to do is we want to calculate the size of area B under the new curve. Right? So we want to calculate the size of this triangle here. Right? That would be, has a base of 40, a height of 20 divided by 2. It has an area of 400. We want to calculate the area of this rectangle here. That has an area of 20 times 20, another 400. We want to calculate the area of this triangle here. It has a base of 20, a height of 80, divided by 2, 800. If you add up 400 plus 400 plus 800, right, we get B has an area now of 1600 under this new Lorenz curve. Since A, right, this area here, everything in white underneath the line of perfect equality, right, is going to equal 5,000 minus 1600. Right, we know A is going to be equal to 3,400 in this example. That means the Gini coefficient is going to equal to 3,400 divided by 5,000. It's going to be 0.68. So how does automation affect inequality when the owners have robots? Well, it increases inequality and increases the Gini from 0.4 originally to 0.68. So here it increases inequality a bunch. Now suppose instead that the workers develop a new robot technology to do half the work. For simplicity, it costs nothing to build the robots, so that every worker still earns $30,000 but works half as many hours. Well, what would happen then? Well, then worker hours would be halved, but GDP and the Gini would be unchanged, right? We would be back to our original Lorenz curve for how income is distributed, except workers would only work half as many hours as they worked originally. Right? The key thing to understand here is automation only increases inequality if the capitalists own the robots. Right? And this goes back to a topic that we addressed at the very beginning of the semester, right? Where the Luddites famously destroyed power looms because capitalists were using them to put home weavers out of work. Ultimately, though, right, this technology didn't put workers out of work in the long run. Right? Ultimately, political reforms were used to ensure that workers benefited from technological progress, right? In the form of shorter work hours and higher wages. Today, Uber's technology hasn't increased drivers' wages, right? It's actually decreased the wages of both drivers for Uber, but also cabbies. But again, the technology itself doesn't necessarily have to reduce those wages. The reason it's reduced the wages is because Uber owns it and it uses it to make as much profit as possible. But if instead workers own the technology, or if we mandated, right, through laws that drivers for Uber had to be paid at least a certain amount of money, right, more money than they're currently being paid, we could have used the technology, right, in a way that actually would have slightly increased wages for those drivers. Right? In fact, it's useful, right? right, for drivers to be connected to riders through an app. The problem with Uber is that all the benefits have gone to riders, right, who now pay lower fares than they used to pay before there was this app, but also to a company that takes a big cut of all the fares for themselves, right? So essentially what I want you to take away from this sort of example is that automation does not necessarily increase inequality. It depends on the institutions that we set up and who ultimately gets to benefit from that technological progress.